Hi, my name is Manish Gupta, and in this video, I'm going to talk about visual chain of thought. So let's get started. What is visual chain of thought and the related problem, multimodal infilling task? So look at this. Look at these two pictures, and then the caption along with them. A person is biking to class. A family gathers at a hospital. Right? A person is biking to class, and family gathers at a hospital. And the headline is biking to class brings family together at hospital. Now, you can't make much out of this. Clearly, there is some information missing in between, right? So why would a person biking to class lead to a family gathering at the hospital? And this is where the multimodal infilling task becomes important and interesting. So, how about infilling this with this multimodal information? The text part is the person falls off his bike and then showing this picture in between. Yeah. So sequences naturally have logical gaps between elements that can limit the reasoning. And this visual chain of thought, the idea is to bridge this gap with multimodal infilling, right? So this is the multimodal infilling as you see it. Now, chain of thought sort of has allowed models to decompose problems in a human-like fashion and therefore come up with really awesome outputs. However, it is text only for most of the models, right? So incorporating visual augmentation, as you see here, into reasoning is essential, specifically for complex and imaginative tasks. So even humans sort of imagine visually and then essentially try to complete long form text generations. Right? So visual COT essentially leverages the COT chain of thought prompting with visual language grounding to recursively bridge these logical gaps within the sequential data, which has these logical gaps, right? So it uses visual guidance to generate synthetic multimodal infillings using stable diffusion, as we will see soon, that add consistent and novel information. This is new information, and this is consistent with respect to the surrounding information, right? To reduce logical gap, right? Formally, multimodal infilling task is basically generating an in between or an infilling image and an infilling text given the surrounding multimodal information, the previous timestamp and the next timestamp. So how does Visual COT do multimodal infilling generation? So well, it does it in the following steps: task unification, multi-point foveation, and novelty-driven recursive infilling. Okay, so let's talk about what is text unification, task unification. Well, some tasks are basically text-only data, right? So essentially, for example, if somebody is giving you steps to follow in a particular recipe or steps to follow to install something, right? That's basically just text-only sequence of tasks or other is a text-only sequence of instructions. It's a text-only task, right? Uh, Versus there could be other tasks which are multimodal in nature. For example, this one was a multimodal example. So it has like two steps in the process, and well, they are both multimodal. They're multimodal in nature in the sense you have an image and you have a text. So for text-only tasks, you need to basically also bring in images, right? So basically, so that you can actually then do multimodal infilling. So the first step is if it is a multimodal task, then you don't need to do anything. But if it's a text-only task, well, you generate visual information. So you generate visuals from the input text data using stable diffusion. Now, again, for every time point, you just don't use the text to generate one visual. You actually generate multiple candidates, and then you use the clip model, similarity between that visual image that you have generated and the neighboring text, so as to decide which of these candidates is the best fit for that time point from a visual perspective. Right? The second one is what is called as multi-point foveation. In simple words, it just means coming up with a nice, a short description for the entire process, right? So process basically means multiple steps, multiple multimodal steps, and multi-point foveation is just about coming up with a caption for the entire process. Okay, so the way it is done is basically, if you have like some images, like these three images, you generate captions for each image in the image text pair. So essentially, you have these images, you can generate captions for them. And then you use GPT to generate summary. So you use GPT and that gives you the summary, which is basically called as the foveation in their paper, right? So, but the idea is to basically come up with a nice summary which talks about multiple interesting points, multiple interesting things going on in the entire process. Okay. So that's that. Now, the third step or the most important step is actually doing the infilling. So And they propose to do the infilling in a recursive manner until there are logical understanding gaps in the entire process. Right? For example, given this image, which is only harvest honey from a 12 to 18 months old hive that doesn't experience temperatures below 18 degrees Celsius. And then this step, use hive tool to separate the top box from bottom two boxes of a beehive. In between that, you can actually bring in a step 0.5, right? So this is the first level of infilling, where the idea is to use the frames of the hive to assess the amount of harvestable honey. And then, between these two, you can actually bring in a step 0.25. And between 0.5 and 1, you can actually bring in a step 0.275 by doing depth to infilling. But then should you actually bring in more steps or not, needs to be decided based on how consistent and how, is there still any logical gaps which are left or not, right? So now how is this infilling done? Well, the idea about infilling is to generate multiple depths of infillings to add valuable, new, relevant, and consistent information. Right? The way they do this is basically given to neighboring multimodal pieces of in pieces of information, text plus image. You generate 5 candidate text infillings with GPT-3. So you have the text part, you generate 5 possible candidates using GPT-3. You select the best one using clip similarity with the surrounding visuals. Right? Now, after you've generated this text, you basically again use stable diffusion to generate 4 candidate visuals, and you choose the visual such that it is basically most consistent with the text infilling, again using the clip embeddings themselves. Okay. So how does VCOT perform on VIST and WikiHow? So VIST and WikiHow are two popular datasets. VIST stands for Visual Storytelling Dataset, which consists of sequences of 5 text visual pairs representing a single story. So the idea is basically you have a story and then you can represent it in 5 sentences, or you can actually represent it using 5 photos. So VIST basically contains a combination of that. So it's a multimodal dataset. It contains 5 photos and 5 images in a sequence denoting a story. WikiHow is another dataset. It contains lots of articles about how to do certain things. And then it also contains summaries, summarizing the entire process in steps, in a few steps, like say 4 or 5 steps. Okay, so it's a text-only dataset in that sense. So they experimented with both the datasets and they try to do infilling so as to basically make up for any logical gaps in between. So the quality is evaluated in a human way using 2 metrics, consistency and novelty. Consistency basically means that the infillings maintain the faithful details from the surrounding steps. And novelty basically means that the infillings actually add relevant and new information that accurately bridges any logical gaps across steps. Okay. They compare it with the baseline. So there is a COT plus COI baseline, which is basically doing chain of thought in text separately from chain of thought in images. And also, there is also this random baseline, which basically means that I'm going to randomly take, an output from the generations that are made from the stable diffusion or the GPT-3 models. Okay. Now, if you look at it, so this table basically denotes how many times the VCOT model was better in terms of image consistency, text consistency, or image novelty or text novelty compared to these baselines, right? So now, so smaller numbers in or higher numbers in terms of wins are better, right? So smaller numbers in terms of losses are actually better, right? Smaller the losses, the better. Higher the wins, the better. So as you observe, in most of the cases, wins are more than losses. Wins are more than losses, which basically means that VCOT actually outperform these models where you actually do a chain of thought just based on text or chain of thought based on images only, right? Now, so here is an example. So here is a particular step. By working as a junior 2D artist or runner, you can get your foot into the door and work on blockbusters or TV. Right? And there is this one, as a supervisor, you're responsible for making raw images fit together to create the final product. Now, in between, something needs to be put up. And nicely, this visual chain of thought method basically brings in this image, which sort of is a nice fit between these two, right? The last image. Right? And it also brings up this nice text. With experience, you can move up the ranks and become a 3D artist or VFX supervisor. This is also pretty interesting text to be put in between, right? Compared to a baseline, which doesn't really come up with a very consistent image in that senses. Nor does it, I mean, well, it comes up with some reasonable text, but not a very consistent image fitting in between these two. So lastly, how does VCOT perform, for downstream tasks on actual VIST and WikiHow datasets? Well, now if you really look at the kind of infilled information that is brought in by VCOT, let's look at this. So these are VIST images. So this is basically some sort of a story being told by these VIST images. And then there is a story right there. So there's a chain of thought story and there's a visual chain of thought story. So if you look at basically the text-based story only, I took my son to watch the sunset and admire the beauty of nature together. We got out of the car and looked at a presentation of flowers, admiring the sky and the beauty of the sunset. Well, that doesn't look like flowers too much here, but anyway. So we shared a peaceful moment together, taking in the beauty of the city and the flowers. We looked up the blue sky and the white sky, blue and the white sky, appreciating beauty of nature in the peaceful moment. We shared a special moment together, right? So as against that, if you look at visual chain of thought, it'll basically give you much better, more coherent and descriptive pieces of information. So on my way home from school, my son and I enjoyed beautiful view of the sky and flowers. Okay. We watched the sunset behind the mountains, admiring the beauty of the day. So that's basically a very good description of this image, right? We shared a smile in the backseat of the car, content with a peaceful view of the city. So it's a good view of the city. We had picked a presentation of flowers from school, which we admired as we drove home. This looks like a nice presentation that way, right? The sky was blue and so on and so forth, right? So it basically, qualitatively, it looks like a visual chain of thought sort of gives you better infillings for on the VIST data set. Similarly, on the WikiHow data set, it basically gives you interesting completions, interesting summarization of the WikiHow articles, adding information, which is very relevant to the overall article and very relevant to the overall story in that senses, right? Or the overall steps in the process. Okay. So they also introduced two new metrics here, so as to manually evaluate how good the visual storytelling based on VCOT is, or how good summarization on WikiHow is compared to baselines. So these two metrics are coherence and descriptiveness. Coherence basically confirms that the output logically flows together as an interesting and creative story, the one that is created here, right? Descriptiveness sort of verifies that the generated summaries describe accurately and with detail the steps of the how-to article as you see them here, right? So basically, here are the quantitative results. So they compare on WikiHow and VIST data sets, and as you can observe, right? I mean, they compare it with the chain of thought or chain of images or no infilling at all, right? Um, and again, all of these things that you see here, and of course, you compare it with Oracle, the reference step, right? So as you can see here, these are again how many times VCOT wins over these baselines versus loses over these baselines. So again, a higher number on the wins part on this part is better, while on the loss part, a lower number is better, right? So as you observe, most of the cases, basically, VCOT is sort of winning because the wins are greater than losses. In terms of consistency, VCOT is almost the same as chain of thought in some ways, but then in general, it is better compared to other baselines. In terms of descriptivity, however, as you can observe, chain of images basically gives you more descriptive, more descriptive um, summaries compared to VCOT, as can be observed here, right? So, but other than that, yes, VCOT does perform better in terms of novelty and consistency compared to the baselines. Similar observations can be made in the VIST data set. So in the VIST data set, also you see most of the times in terms of novelty, consistency, and coherence, VCOT performs better compared to the baselines. Okay, so in summary, in this video, I talked about visual chain of thought, which is about generating synthetic logical multimodal infillings. It combines chain of thought with visual guidance to recursively generate multimodal infillings using stable diffusion. These multimodal infillings bridge the natural logical gaps between sequential elements, and it adds infillings to sequences while maintaining consistency by augmenting novel and relevant information. They experimented with VIST and WikiHow datasets to show how their method is very effective. Okay, hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.